Hi guys, in this video would be presenting about work done in physics, work done in chemistry. Now like in earlier video I had talked about reaction, enthalpy of reaction when enthalpy of formation is provided or when enthalpy of bond energy is provided, how the equations were different and how there could be confusion and how I tried to explain you the confusion could be sorted out. Now there I had assured that I would be coming again with few more videos where such confusions are there. So here in this video I am going to talk about work, system surrounding in physics and in chemistry. So to begin with, in chemistry, if surrounding does work on system, it's considered to be positive. Whereas when system does work on surrounding, it's taken as negative. Similarly, when heat is provided to system by surrounding, it is taken as positive. And again, when system provides heat to surrounding, it is taken as negative. This is chemistry part. Whereas in physics, what we observe is other way around. In physics, we observe that when surrounding is doing work on system, it's negative. Whereas when system is doing work on surrounding, it's taken as positive. Same thing about heat also. When heat provided by surrounding to the system is taken as negative, but when system is providing heat to surrounding, is taken as positive. Now this entire video is about dealing with this confusion. Alright, so you have got to be really very careful while explaining physics, while explaining work in thermodynamics of physics, work in thermodynamics of chemistry. Would sort out this mystery, but my main contention is when you are doing numericals. While numericals, the formula that you use should be very careful. Main purpose of this video is to enlighten you about physics and chemistry, thermodynamics, work, system and surrounding. Okay? Happy viewing. Let's see how it works out for you. So in case of chemistry, what do we observe? We observe that in case of compression, work done is by the surrounding on the system is taken as positive. And at the same time, even the heat supplied by surrounding to the system is positive. That is in case of compression. In case of expansion, system when does work on surrounding, it's taken as negative. System when is providing heat to surrounding, then also it is taken as negative. Now just to keep in mind, I just talk about new generation, right? New generation wants everything from their parents. So anything coming in is positive. If anything they have got to shelve out, it's negative. Alright, very easy to identify yourself into this system. Okay, now why is it all this? Of course, I'm not talking about the current generation, but I'm talking about the system in chemistry. Why does it happen? So this is a cylinder fitted with a frictionless movable piston. Now our mission and this initial volume which is there is VI. Alright, now our mission is expansion. Alright, the gas which is there inside has to apply force, would be applying force over here, applying force over here and push the piston out. Now suppose if it pushes the piston out till here. Alright, the piston is being pushed out by gas till here. Now this volume becomes VF. Alright, and there's also external pressure acting on it, which is PEXT. So what's the situation? The situation is force of gas inside the cylinder forces the frictionless piston to this level. So initially the gas was occupying volume Vi, now the gas is occupying volume Vf. So it has moved the piston from here to here. Alright, now as per thermodynamic law, best work is obtained when the piston is moved slowly. Alright, so generating small displacement of dx, 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 dx. So if I intend to write formula, then how do I proceed? First of all, let me write formula for force. Force is equal to minus PEXT into A. Now first of all, why is this negative there? Now see, force is in this direction, whereas external pressure is acting in this direction. These two are in opposite direction, so owing to which we get this negative over here. And we know formula, we know pressure is equal to force upon area. So if we want in terms of force, it would be pressure into area. So done. Alright, now what I told is we are supposed to do work, small work. So it is F into dx is equal to minus PEXT A dx. Alright, so pressure external A dx. Now A into dx we know is volume. So what we can write here is, we can call this as small work, and this we can call it as PEXT into dV. Alright, now we have got to integrate it. Alright, on integration, suppose if I integrate, I would integrate it here from V1 to Vf, from Vi to Vf. So this would also be integrated from Vi to Vf. Now so this becomes capital W, and now this would become minus PEXT Vf minus Vi. Alright, so the formula gets to minus PEXT into del V, where del V is V final minus V initial. V final minus V initial. Now this is the reason why we have negative sign whenever there is expansion of gas, the system does work on surrounding, so this becomes negative. Alright, now let's understand how does it become positive in case of physics. Now let's try and understand in case of physics. In case of physics, whenever work is done on system, it is negative, and whenever heat is supplied to system, it is negative. That is in case of compression. In case of expansion, whenever system does work on surrounding, it is positive. Whenever system is providing heat to surrounding, it is positive. So these are the things for compression, where V final, in case of compression, volume final is smaller than volume initial, whereas in case of expansion, volume final is greater than volume initial. Now in case of physics, what happens is, we are talking about internal pressure. The pressure, assume that is acting this way. Pressure is acting this way. Obviously, that's why the force is also in the same direction, because we know pressure is equal to force upon area. Alright, so now as we did in our earlier case, let's write equation for force. Force is equal to pressure into area. Now here pressure is acting in this direction, force is also in the same direction, so there is no negative sign, which we had seen in case of chemistry. Alright, so what happens is, now this force creates a displacement. Now say it creates a displacement where this initial volume was Vi. Now it displaces the piston upwards, so it brings it over here, and now the final volume is Vf. So from initial volume Vi, it went to final volume Vf. Alright, now as we did in case of our earlier, in case of chemistry derivation, it was what? We have got to find the work done. The work is force into displacement. Now there already I told, whenever the work is done with smaller portions of displacement, that is dx, 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 we get the best output as per law of thermodynamics. So here also what we do is we make it as small work dw is equal to f dx, which is equal to pa into dx. Right? Now we know that a into dx is dv, p dv. Alright, now what we intend to find is the total work. So we have got to integrate this dw. So when we integrate dw, it becomes the work, total work, and here integration of dv from vi to vf. Alright, so this would become p into vf minus vi. Alright, so this would be the formula for work is equal to p del v. So here what we found is it's positive work. Now this is also in case of expansion. In case of expansion, positive work. Here in case of expansion, it was negative work. Alright, now furthermore, now here also, here Vf is greater than Vi. So even if we substitute over here minus P E external into Vf minus Vi, Vf being greater than Vi, this would be positive value, so the work would still be negative. Alright, so in case of expansion, the work is always negative. Whereas in case of physics, here again Vf is greater than Vi. So again W would be equal to P into Vf minus Vi. W would be equal to P into Vf minus Vi. Now since Vf is greater than Vi, so this also would be positive. So here again the work would be positive. So for expansion, work would always be positive. So this was the state with this expansion. Now let's understand what happens with compression. Now in case of compression, final, it is being compressed. It is being compressed from here to here. So this would be Vi and this would be Vf in case of compression. So Vf would be lesser than Vi. Alright, so let's get into here. So Vi is greater than Vf, or Vf is lesser than Vi. So W is equal to P into Vf minus Vi. Since Vi is greater than Vf, so the value for this would be negative and the work done would be minus P del V. So work done would be negative. So that's what we see over here. In case of compression, the work done would be negative. Alright. We didn't check it out for compression in case of chemistry. So in case of chemistry, again the same story. In case of compression, Vf is lesser than Vi. So let's put in the formula. W is equal to minus Pext into Vf minus Vi. Now here Vf is smaller than Vi, so it is negative value. So, or rather I would say Vi is greater than Vf, Vi is greater than Vf, so negative greater value. So this also would have negative value. So work as a result of which would become positive P external into del V. Alright, So that's the reason why during compression we have positive work. All right. So these are the reasons why in case of chemistry we have work done on system positive, and in case of physics, in case of compression, we have work done on system negative. So guys, I hope this video was helpful in understanding theoretically the difference between work done in physics, work done in chemistry. Alright, my following video would be on mathematical aspect. Okay, so it would be about numericals to enlighten you further about how you should discriminate between physics and chemistry, work, numericals. Alright, see you there.